Welcome to the video tutorial solution to question 2 and question 3 of the extension section of the Engbound Python worksheet. So in this session, we're going to first walk through question 2 in the extension, then move on to question 3. So to start off with question 2, I'll just make an annotation here to say question 2. So question 2 reads, rearrange the data in a way that makes sense, and a hint was given. And it says, have a think of what the relationship between the mass of the bodies and the force should be. Then try to use the sort function in the NumPy library. So this question is trying to hint at equation 1, which is F equals mg. And if you remember the way the plots looked like in equation 1, when you plotted it as both a scatter plot and a line graph, you would observe that we saw essentially what was a straight line. And in this case, so that means we just need to arrange the data in a way that we get a straight line. And to do this, you'd see that to get a straight line, you basically start from a smaller value to a bigger value. So as you can see on this graph here, we essentially start from a smaller value to a bigger value to get a straight line, because when we plotted the data as we were given here in table 1, you can see that when we plot it as a straight line, we get this random graph that makes no sense. And this is because the data points are not ordered correctly, like it's not in an ascending order or a descending order. So to do this, all we simply need to do is to apply the sort function in NumPy. As you can see, I have imported my NumPy library here, and I remember it as np. So in this case, I'm going to try to sort my mass data and my force data from table 1. So to do that, I'm just going to make a new array. I'll call this m underscore sorted and say equals, then I apply the NumPy sort function, which is np.sort. Then in brackets, I put in the array I want to rearrange, and in this case, it is my mass array I want to rearrange for my sorted mass array, which is short for m sorted. So in this case, I just put in m, and I'll put in f sorted as well in this case, and which is the name for the force array I want to rearrange, and numpy.sort, then into bracket f. And when I run this in the variable explorer, you should see that the arrays have been rearranged. So this is our original force array here, and when we apply the np.sort function, you can see that the array has been rearranged in ascending order, so from smallest to biggest. And this is the same for the mass array as well. Originally it was random as positions for the value, but in this case it's ordered in an ascending order, so smallest to biggest. And that is what question 2 requires you to do. And then on to question 3. We were told to plot the newly arranged data, 1 as a scatter graph and 2 as a line graph. So essentially what we did in question 1 is what we've been asked to do in question 3 to the data we just rearranged. So we're going to be focusing on this newly rearranged data for question 3. So firstly, to plot it as a scatter plot, we can simply, if you remember, I said if you have a piece of code that you've written before and you know works and you need it to do something else, you can just copy that code and paste it. So this is the function, the set of codes rather, that I created through, which allows me to create a scatter plot. So in this case, I can just copy it. Then in my scatter function, I can change the names of my x component and my y component, or my x values and my y values, to the data I want to plot in this case, which is my m sorted and f sorted, which is my rearranged mass and force. So in this case, you'd see that when let me just clear this first and show it to you. So when I run, let me clear that also. When I run the script, you'd see that this graph here, the very first graph is this here, which I plotted the original data in table 1. You can see that graph is exactly the same as the new scatter plot I made for the rearranged data. But watch this. When I plot the rearranged data as a line graph, so I'll copy the section that allows me to make a line graph, Ctrl C. Then I change it, M sorted, F sorted, so change that. So change that, clear my workspace, and I can clear all of this as well. So when I run that, you can see my scatter plots for the original data and the rearranged data are exactly the same, but the line plot of my original data compared with my rearranged data is different. So essentially here, what we're trying to notice or understand is the fact that sometimes if you have experimental data or like a random data set, you need to arrange your data in a way that makes sense before you perform any analysis on it. Because essentially, if I take the original data and I try to perform an analysis on it, or like try to figure out a mathematical expression that describes this, like I have no idea, because it's so random, and the way the line goes up then comes down, like gives me nothing sensible. But when I rearrange my data based off of equation 1, when I know what the relationship between mass and force is, I can sort of get an idea to say, okay, it's gonna follow potentially a straight line, because if you think about F equals mg, it's the same as having the equation of a straight line, which is y equals mx plus c, where y is fg, x is m, in this case our x-axis, and g is the gradient, and in this case F equals mg, that means c is 0. So it's just getting you to think about what your data should look like, what trend or what relationship the x values and the y values have between them. And so that's the idea, like this question is trying to get you to think about. So you can then see that, like, oh, my data follows almost a kind of like straight line profile or straight line trend. So you can then say, okay, if I'm supposed to like describe the relationship between my mass and force, I know it's going to be some sort of straight line equation. And that is what the question is trying to get you to think. And in part 3 of question 3 in the extension section, it says, do you notice a difference between the new and old graph? And that is the difference we're noticing, that like when we arrange our data, we can see clearly the relationship we expect. That is if we know the relationship beforehand. And why I say beforehand is because we've been given equation 1. So we know the data should follow equation 1. But in a case where you have no idea what the relationship is going to be, you can arrange the data and plot it and see roughly what the profile is. And from there, you can decide that, oh, this is like a straight line, or this is like a quadratic profile, or a logarithmic profile, or a parallel profile, or whatever profile. So that is the idea behind question 3. Thank you for listening.